Okay, now we're looking at actual problems involving finding the area of a regular polygon. The formula is 1/2 AP, where A is the apothem, P is the perimeter. Now finding the perimeter is really easy in this case because they've given us the length of one side. Since this is an octagon, that means there's 8 sides. Each side is 15, so we do 15 times 8, which is 120 inches. The next thing we need to do is we need to figure out the apothem. If we know the apothem, then we're set. Now remember from the last section, we can cut this octagon into pieces. Each piece is a triangle, and the angles for the triangle should all be the same because it's a regular polygon. In this case, we've cut it into 8 triangles because there are 8 sides. Therefore, since this is 360 degrees, to find the measure of angle PRQ, that is going to be, actually we don't need to do that. We'll do that in the next problem. Sorry. Let's just back up here. This is actually an easier problem because if we know this is 15 and I draw my apothem, we know that the apothem is an angle bisector, but it's also a perpendicular bisector. So PQ is 15, but if we call this S right here, we can say that SQ is half of 15. So if I draw that triangle separately, where the right angle is at S, up here is R, over here is Q, they already give us that this is 19.6 inches. This length right here is going to be half of that 15, so it's going to be 15 over 2, or 7.5 inches. We want to know what the apothem is, which is RS. So in order to do that, we use Pythagorean theorem. So we would say 19.6 squared is equal to A squared plus 7.5 squared. And we'll get out our calculators, and we'll have 19.6 squared, which is 384.16, and that's equal to A squared plus 7.5 squared, which is 56.25. We're going to subtract 56.25 from both sides. If we do that, let's see, we have 384.16. We have 327.91. Now we're going to take the square root of both sides. And if we do that, we get approximately 18.11. Now we're going to keep that number on our calculator. We'll go up to the top, and we're going to plug everything into this formula right here. If we do that, we get 1/2 18.11. Do not use this number. Use the number that's already on your calculator. And we're going to multiply that times 120. So that's our apothem and our perimeter. To make it easier, I just do half of 120 is 60, and then you can take the number that's on your calculator and multiply it times 60. We get our answer, which is 1086, or 1086.50, and that would be square inches. Okay? So again, perimeter is found by 8 sides with 15 inches apiece, which is 120 inches. We know that the whole length from P to Q is 15, so from S to Q it should be 7.5. Using Pythagorean theorem, again we found this was 7.5 because it's half of 15. We use Pythagorean theorem to find RS. Oops, back it up. And we get what I told you. and then we plug everything in. If we do that, our answer is 1086.5. I said 0.50, so I rounded differently. Alright, for this next one, we've got a nonagon. In this case, they don't tell us what kj is or what the length of any of the sides are. So here we're going to have to use sine and cosine to figure out what km is and to figure out what lm is. So first of all, we know that the measure of angle klj is found by, remember how on the last one it was 360 divided by 8 because there was 8 sides. So this time it's 360 divided by 9 because there's 9 sides. That means that this angle right here, from here to here, is 40 degrees. We also want to know what angle KLM is. And KLM, if you remember, LM is the apothem and it's an angle bisector. It's also a segment or a perpendicular bisector. So since it's an angle bisector, we know that KLM is going to be half of that big angle. So that ends up being 20. So right now, if I was to draw the triangle, I'm going to draw it in this corner here. I'm drawing the triangle where this is L, this is M, and this is K. This angle is 20 up here. We want to know what angle LKJ is, or LKM is. So I want to find LKM, which is this one right here. Remember that these two add up to 90, so therefore 90 minus 20 gives me the angle that we want, which is 70 down here. Now, if I call the length from K to M, if I call that X, and I call LM my apothem, or A, that means this is X here, and this is A. We're going to use, since we know the hypotenuse LK is 4, we're going to use sine of 70, which would be opposite, which is A, over hypotenuse, which is 4. We're going to use that to find the apothem. Multiplying both sides by 4. Those cancel, and we get A is approximately whatever 4 times sine 70 is. 4 times sine 70. And we get 3.76. And this is units. To find MK, we are going to use cosine because it's adjacent over hypotenuse. So it's cosine of 70 is equal to, this time, x over 4. Again, multiplying both sides by 4. Those cancel, and here we get x is approximately 4 times cosine 70, and this is 1.37 units as well. But we also need to know what kj is. Kj is the whole distance across. Remember, this is km, but we want to know what kj is. Because both of those are equal, we know this is going to be 2x. So if I multiply that answer that's on my calculator by 2, I get approximately 2.74 if we round. And both of these are units. Now, in order to find the area of this nonagon, what we need to do is, again, use the formula that we've been using all along. Oh, before we do that, we need to find the perimeter. Now, the perimeter, we know that the length of one of these sides, kj, is 2.74. Since there are 9 sides, I'm going to multiply 9 times that 2.74. Okay? So the numbers on our calculator, so we're going to say times 9, and we get 24.63 units. To find the area, we're using 1/2 AP. We know what our A is. We know what our P is. Try to use as much what's on your calculator as you can. So it's going to be 1/2. Our A is 3.76. And our P is 24.63. I'm going to multiply the answer that's on my calculator by 0.5. And then after I do that, I know that 3.76 is the same as 4 times sine 70, so I'm going to say times 4 times sine 70. And if I do that, I get my answer, which is approximately 46.28 square units. So we'll say units squared. Okay? So watch. First of all, 36 divided by 9 is 40. That's this angle right here. We know that half of that is 20, so this angle right here is 20. So now you're going to use trig ratios to find this. Well, they did it differently. They used the 20. I used the 70. I think it's easier that way. They used sine of 20 to find this side, and then they used cosine to find this one. So sine of 20 is mk over 4. So mk ends up being this. Lm ends up being this. And we wanted to find the length of one side, so jk is the same as 2 times mk. So that's 8 sine 20, and the apothem is here. We want to know the perimeter, and that's 9 times all of this, 24.6, which is what I got. And you plug everything in, you get 46.3 square units. Alright, we're doing the same thing with this hexagon. I'm sorry, with this pentagon. The nice thing is we have our apothem, so we're going to use Pythagorean theorem to find this distance here. We have 8 squared is equal to 6.5 squared plus, we'll call this x squared. So that is 64. Is equal to 42.25 plus x squared. We're going to subtract 42.25 from both sides. Those cancel. And if we subtract those two, we get x squared is equal to 21.75. We're going to square root both sides. And if we do that, we end up with x being approximately 4.66. We need to find the perimeter, so first of all we're going to find 2x. So we're going to multiply that answer times 2. We get approximately 9.33. And to find the perimeter, we know that there's 5 of those. So we would say 5 times that 9.33. Again, use the number that's still on your calculator. So we're going to take that number times 5. We get 46.64 units. Then we have all the information we need. Area is equal to 1/2 6.5 times 46.64. I would just get your calculator at this point, and the number that's still on your calculator, you're going to multiply that times 6.5, and then you're going to multiply that times 0.5. If you do all that, you should get 151.57, and this time it's square units. Okay? There we go, 46.6, 151.5, I got 151.6 about. If you're that close, we're okay. Alright, for this one, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 sides, it looks like. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 sides. So if the center is right here, I can draw a line here, and I can draw a line here, and if we call this A, B, and C, we can say that the measure of angle ABC is equal to 360 divided by 10, because there's 10 sides. So there would be 10 angles. This gives us 36 degrees. If I draw a line here, that's my apothem. And if I call that D, then I know that the measure of angle ABD is going to be 36 divided by 2, which gives me 18. And then I want to know what this angle is. I don't know, I just like that angle better. I'm going to do the measure of angle BAD, which is 90 minus 18, which is 72. So this angle is 72. If I draw that triangle up in the corner, so that this is D, this is B, and that's A, we know this is 72 degrees. We know BD is our apothem, and we don't really need to know this part because we already have it. In fact, we can find our perimeter right now. We know there's 7 is the length of each side. We know there's 10 sides, so that gives us 70 units for our perimeter. Since we know that the whole length is 7, we know this part right here is 3.5 going from A to D. So if I do, it looks like tangent this time because opposite over adjacent. So we're going to have to use tangent of 72 degrees. That's going to equal the opposite, which is A, over 3.5. We're going to multiply both sides by 3.5. 3.5's cancel, and our apothem is, give me a sec, 3.5 times tangent of 72. That gives us approximately 10.77. Area is equal to 1/2 AP, or in this case 1/2 10.77. Don't use 10.77, use what's on your calculator. So what I would do is say half of 70 is 35, and take that answer that's on your calculator and multiply it times 35, and you get 377.02 square units, where the perimeter is 70 and the area is 377.02. Okay. Here's one with a triangle. This one's actually really easy. I'm glad we're doing this one, because if we look carefully, I'm going to make this easy on you. This is where your 30, 60, 90 comes into play. If you've memorized these, this will be very easy. If I draw a line here and a line here, well, actually I don't need to. Yeah, I do. If I draw a line here and a line here, this angle right here, which I guess we'll call ABC, measure of ABC is equal to 360 divided by 3. 3 sides, 3 angles. So that gives us 120. If I call this D, that means that the measure of angle, let's see, ABD is going to be half of that, or 120 over 2, which is 60. And if I want to know the measure of angle BAD, that's going to be 90 minus. If this angle is 60, that one is 30. Do you see the 30, 60, 90? 90 minus 60 gives me 30. Okay? And all equilateral triangles will give us this 30. Now, hopefully you can remember this, otherwise you have to use sine, cosine, and tangent. But if I look carefully, in a 30, 60, 90 triangle, this is A, this is 2A, and this is A rad 3. Yes? So if you notice, this side is the A, this side is the 2A, that makes this 10 here, and that makes this length right here 5 rad 3. Okay? So we know that the measure of, we know that AD is equal to 5 rad 3, and we know that AC, which is the side of a triangle, is going to be 2 times 5 rad 3, which is 10 rad 3. Okay? Now to find the perimeter, there's 3 of those, so it's 3 times 10 rad 3, or 30 rad 3, and that's units. We know our apothem is already given to us, that is 5. So to find the area, it's 1/2 AP. This gives us 1/2, again, apothem of 5, and perimeter of 30 rad 3. Half of 30 is 15. 15 times 5 is 75 rad 3. And if we calculate that, we get 75 times rad 3. That gives us approximately 129.90 square units. There we go, 30 rad 3, or 52.0. That's 129.9. Okay? In exercises 3 through 5, which ones can be done with special right triangles? That one could be, but the other ones could not be done. I don't know why I'm having troubles here. Okay, so just exercise 5. And we're done. Thanks.